Good morning, dear students. My name is Ferhan Mazher, and today is the 17th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O Levels Physics, and a very important document before the exam we are studying, and that is called Learner Guide. Here we are taking the different topics, a list of the topics which is given by the Cambridge, and we are checking that if we know and if we have practiced those things or not. This is, I have done 3 videos already, the part A, part B, part C, and now this is the part D on this document. So let's start today's work. So here we go. So we are studying this learner guide issued by the Cambridge O Levels, and this is good for the examination from 2016 to 2022. So we are on the topic number 9, transfer of the thermal energy. The first topic is conduction. Conduction distinguish between good and bad conductors of heat. You see in the good conductors and the bad conductors, one experiment which is very famous is the good conductors are through which the conduction of the heat can take place easily, and the bad conductors through which the heat cannot transfer that efficiently by the conduction. So one good method of one very famous experiment you remember is that we have a hot water tub, and we have placed different rods of different materials, and they are, some part of those rods is inside that hot water, and on the some part of those rods is outside of that water tub, and on the end of those rods we have applied some wax, and then we have put some peas on them, and the rod from which the pea drops first, because the wax will melt when the heat will reach there, and the pea attached to the rod will drop on the ground, that will be a good conductor. That experiment is very important. If you know that, then it's good. Normally, metals, they are very good conductor of heat, and the non-metals, they are not that good conductor of heat. So air is a bad conductor of heat. Water is also a bad conductor of heat. These are the famous bad conductors of heat. Air is a bad conductor. Water is a bad conductor. Wood is bad conductor of heat. Plastic and rubber, they are bad conductor of heat. They do not let the heat pass through them by the process of conduction. Describe the heat transfer in solids by the movement of the molecule. You see, and this is very important question. In a solid, the end of the solid, which is at the hot side, where the temperature is higher, the molecules there, they absorb the heat, and they start vibrating vigorously. The amplitude of their vibration increases. So they collide with their neighboring molecules, and they make their neighboring molecules vibrate vigorously. And so the amplitude of vibration of their neighboring molecules also increases, and they make their neighboring molecules vibrate vigorously. In this way, by the vibration of the molecules, the heat is transferred from the hot end to the cold end. So this is how you describe this method, by the vibration of the molecules. Another very important thing about the conduction of the heat is that, for example, you have metals, and in the metals, the heat will transfer from one end to the other end by the vibration of the molecules. But another thing is very important, because the metals have free electrons in them. So the free electrons, they can flow from one end of the metal to the other end of the metal. So the free electrons at the hot end, they will absorb the energy, their kinetic energy will increase, and they will flow and they will go to the cold end. And when they will reach the cold end, they will collide with the atoms there, and they will make them vibrate vigorously. This process is called free electron diffusion. This process is called free electron diffusion. So that's why the metals are better conductor of the heat, because they have the free electrons in them. So the free electron diffusion process will take place in them. So there are two ways of conduction taking place in the metals, by the vibration of the molecules and by the free electron diffusion. So both these methods you have to know, and if you know them, put a tick here. So another very important thing, the transfer of energy which takes place in the liquids and gases, is convection. In the convection, what happens? The convection can take place in the liquid, or it can take place in the air. So it comes in paper, and you have to describe that process. For example, we are talking about water, and you heated the water from the bottom. So the molecules of the water, they will move away from each other when they will be heated. So the water will become less dense, and it will become hot and less dense. So this less dense and hot water will rise upward. From the top, the cold water, which will be more dense, that will sink downward. So this will set up convection currents. And by the help of the convection currents, the heat will be transferred uniformly throughout the liquid or throughout the gas. One very important thing is that when you set up convection currents, if you set up the convection currents by heating, the heating will be done from the bottom. But when you heat from the bottom, the convection currents will go up, and from sides they will come down. So if you are doing this by heating, the heating will be done from the bottom. But if you are setting up convection currents by cooling, then the cooling is done from the top. Because from the top, when you cool, the air will become, or the liquid will become dense, it will go down, and from the bottom, the relatively hotter water or hotter air will go up. This will set up the convection currents. So if you are doing it by cooling, it will be done from the top. If you are doing it by heating, then it will be done from the bottom. And it's very important whenever you are describing it, that when there will be a change in the density, and due to the change in the density, the convection currents will set up in that air or in that gas or in that liquid. Okay. So put a tick if you know this process. Radiation is the one process which do not require conduction and convection. They both, the mediums, they require medium for their transfer. But you know, the radiation, it do not require medium. So the radiation is from the hot body, whatever is the hot body, infrared radiation is given out. So infrared radiation is electromagnetic wave, and it do not require medium. So from the hot body, the infrared radiations are given out, and they are given out in all directions, and they do not require medium. Okay. So that is very important thing. Okay, so describe how to distinguish between the good and the bad emitter of infrared radiation. The black color, the bodies who have the dull black color, they are the best emitter of the infrared radiation. That is the reason when you have a radiator, the radiator is always of the black color, because its work is from the hot body, it is giving out the infrared radiation. So it is made of the black color, dull black color. So then it becomes a very good radiator of the infrared radiation. And if you use a silver color, shiny surface, it will be a bad emitter. In the case of absorber, the dull black color is also the best absorber of the infrared radiation. And the shiny surface will be the bad absorber of the infrared radiation. You see, the dull black color is a very good emitter of the infrared. Dull black color is also a very good absorber of the infrared. So at a moment, at a certain instant, how a black body will behave, that depends upon its temperature relative to its surrounding. For example, if you have a structure which is black, and its temperature is higher than its surrounding, then it will be a very good emitter of infrared radiation. But if you have a body of black color and that body has low temperature as to its surrounding, so then it will be a very good absorber of the infrared radiation. That's why, for example, if you make a home and you want it to be, we color it white. Why? So it do not absorb the heat. For example, I'm relatively to Pakistan, I'm speaking, because here its temperature is very hot. So we paint the home white. So the white will not absorb the heat. But if you are in some cold area, you will even then, you will paint it white. The reason is so that the inner heat, the heating system which you have installed inside the home, its heat is not emitted from the walls. So you see, these are the uses of the conduction, convection, and radiation. So if you know these things, put a tick here. Describe how heat is transferred to or from the buildings and the rooms. Okay. So especially we talk about the buildings, and you see in the building, if you want to reduce the transfer of heat from inside to outside or from outside to inside, we make the walls and we make the cavity walls. Cavity walls means you leave space between the two layers of the walls. And because the air will be inside those walls in that cavity, and that will have to reduce the loss of heat. Another thing is we use the glasses in the windows. Those glasses should be double layered glasses. And when we use double layered glasses, you know, they reduce the loss of heat by convection, by conduction, and we paint them white. So when you paint the home or the silver color, you use, then it reduces the absorption of the heat, and it also reduces the emission of the heat from the home. So then he says, state the important methods of thermal insulation of the building. For example, on the floors, we put carpets. For example, on between the cavity walls, we put insulation, and we make false ceiling. You know the false ceiling? When we put false ceiling, that also prevents the absorption or emission of the heat. And you should have full command on these things. Describe how these important methods insulate the building. You should know that. Okay. So every method stops a certain transfer of heat. For example, some methods, they will stop the conduction, some methods will stop the convection, and some will stop the radiation. So you should be able to describe that this will stop this way of the transfer of energy. Okay, so the next topic which we have is topic number 10. That's the principle of the thermometry. Explain how a physical property which varies with temperature may be used for the measurement of the temperature. There are different properties which varies uniformly with the change in the temperature, and we can use them to make thermometers. We call them thermometric properties. For example, the volume of the mercury, you know, that changes with the change in the temperature. For example, the resistance of a wire, that may change uniformly with the change in the temperature. For example, the pressure of a gas may change with the change in temperature. That can also be used to make a thermometer. For example, the colors of some crystal changes with the change in temperature. For example, the EMF produced in the thermocouple, that also changes with the change in temperature. So there are different properties which changes with the temperature uniformly. We can use them to make thermometers. So state some examples. You should have studied them if you know them. So put a tick here. Then he says, explain the need for fixed points. Okay, so whenever we make a thermometer, we use two fixed points. One is called the lower fixed point. One is called the upper fixed point. Lower fixed point is also called the ice point. The upper fixed point is also called the steam point. For example, when you are calibrating a thermometer, means you have no marks on the thermometer. You take the thermometer into, you put the thermometer into the melting ice, and when the level of the mercury becomes steady, you mark the level of the mercury with a permanent marker or something, and we call it the ice point or the lower fixed point. And then you put the thermometer in the steam of the boiling water at 1 atmospheric pressure. And when the level of the mercury obviously will rise when it becomes steady, at the level of the mercury, you put a mark on the thermometer and we call it the steam point or the upper fixed point. Then you divide the distance between the lower fixed point and the upper fixed point into 100 equal parts. And you see that will be a thermometer calibrated in degrees Celsius. So you should know how this ice point and steam point are got. So put a tick here if you know them. Then one very important thing is you should know some very important features. For example, in the thermometer, what is the meaning of the sensitivity? Sensitivity means that the change in the length of the mercury for every degree change in the temperature. If that change in the length of the mercury is larger, we will say it is for every degree change in the temperature, we will say that thermometer is very sensitive, is sensitive. If the change in the length of the mercury or change in the property, thermometric property is smaller for 1 degree change in the temperature, we will say it is less sensitive. To make a thermometer sensitive, in our course, we are talking about a laboratory thermometer and which has mercury in it. So to make something sensitive, you see, one thermometer sensitive, there are some changes which you can make. The bore of the capillary should be small. The diameter of that bore should be small, narrow bore. If you use more volume of that liquid, even then there will be more change in the volume per unit change in temperature. So the thermometer will become sensitive. So these are the few changes which you can make to make a thermometer sensitive. Then we have range. Range is what is the minimum temperature, what is the maximum temperature. Difference between them, a thermometer can measure the maximum temperature and the minimum temperature a thermometer can measure. If you divide that, if you subtract from maximum temperature the minimum temperature, that will be the range of the thermometer. Range is exactly opposite to the sensitive. Okay, so if something is sensitive, its range will be smaller. If it has larger range, its sensitivity will be less. Then we have the linearity of the thermometer. Linearity of the thermometer means for the equal change in temperature, there should be always equal change in that thermometric property. So there should be uniform change in that thermometric property for the equal change in the temperature. If that is so, then we say that there is linearity of the thermometer. Then we have practical thermometer, describe the structure and action of the liquid in glass thermometer, including the clinical thermometer. One very important thing is that the clinical thermometer, one very important feature, clinical thermometer is a thermometer which is used to measure the temperature of the human body, used in clinics by doctors and nurses. It has a very important feature in it. It has a constriction in it. And that is a famous question, that what is the purpose of that constriction? That is a bend in that capillary. So once the mercury has gone, right, its level has gone up. So that constriction do not let the mercury come back into the bulb of the thermometer. So it keeps for example, it keeps whatever the temperature the thermometer has shown, it keeps that reading for a certain time. It do not let the mercury come back immediately. So the doctor, nurse, or anybody who is measuring the temperature will have some time. It will have some time to read that thermometer. And then you must have seen that they give a jerk to the thermometer, and then the mercury will come back from through that constriction. So the purpose of that constriction is that it do not let the mercury come back immediately. So describe the structure and action of a thermocouple thermometer. Thermocouple thermometer, remember, we use two wires of different metals. So especially in our course, the one wire is made of the copper, the other wire is made of the iron. Their two ends are joined with each other, and in the copper wire we put a voltmeter. And the ends of the both ends which are twisted with each other, we call them junction. One of the end is dipped into melting ice, we call it the cold junction. And one of the ends which of those two wires together, twisted together, that is hot junction. We put normally the body whose temperature we want to measure, we put that junction in that body. So a thermocouple will be made of two wires. One is made of iron, one is made of copper. In the copper wire, we put a voltmeter. You see, it's a natural thing that when you have two different metal wires and you twist their ends together, and if one end is on a different temperature, the other end of those two wires is at different temperature, automatically, this is nature, automatically voltage is produced in those wires. More the difference between both the junctions, the more will be the voltage. So the change in the EMF, a change in the voltage is directly proportional to the difference of the temperature between the hot junction and the cold junction. So more the difference between the hot junction and the cold junction, the more will be the voltage produced. So that is the basic formula we use for the thermocouples. Explain the use of thermocouple thermometer for measuring the high temperatures and those which vary rapidly. So the thermocouple thermometer, sometimes they ask you what is the advantage of the thermocouple thermometer. Thermocouple thermometer can measure very high temperatures. Thermocouple thermometer can measure very low temperatures. Thermocouple thermometer is portable. The thermocouple thermometer output can be put into the data logger. So these are the advantages of using thermocouple thermometer. Thermocouple thermometer, and don't use the word that thermocouple thermometer is sensitive. Don't use this word. You can say one thing very important, that thermocouple thermometer, can measure very rapidly changing temperatures. If the temperature is changing rapidly, thermocouple thermometer will be able to record that change in temperature quickly. It measures the temperature very quickly. So if the temperature is changing rapidly, the thermocouple thermometer can measure it. The clinical thermometer or the normal laboratory liquid in glass thermometer, they cannot do this. Another very important thing about these thermometers, there is a formula, and that formula we use in numericals that relates the length of the mercury column and the temperature it shows. So just remember that formula. I hope you have done few numericals on it. And that formula is L theta minus L0 L naught divided by L100 minus L naught equals to theta by 100. L naught, you can write that L theta minus L naught divided by the whole divided by L100 minus L naught equals to theta by 100. What does this mean? L theta means the temperature on the length of the mercury at an unknown the length of the mercury at an unknown temperature. L naught means the length of the mercury when the temperature is 0. L100 means length of the mercury when the temperature is 100. And theta means that unknown temperature. So L theta minus L naught, the whole thing divided by L100 minus L naught equals to theta divided by 100. It's a very famous numerical formula. We use it quite often. And for the thermocouple, we use change in EMF is directly proportional to change the difference in the temperature. So that these two relations are used in the numericals, which normally come related with the thermometer. So if you know all these things, you have practiced these things, you can say to yourself that I know these things. So this temperature, this is clear. So my dear students, in this video, we have done the topic number 9, which was the transfer of the thermal energy. And then we have done the temperature topic, that is topic number 10. And I have tried to review some of the important things which come into my mind. And by practicing for so many years with my students, I have learned few important things about each topic. So I try to share with you. So this was the part D. So we will come back with the part E, and we will start from thermal properties of the matter. So this was part D of this video. So I hope you are learning from this. So I am trying to complete cover the whole syllabus by doing these small videos, and so that you can prepare for your Cambridge exam, which is just around the corner. So thank you very much. If you have taken out time and you are watching this video, thank you very much. Do share the link of this video if you find this video interesting and informative. Do share the link of this video with your friends, with your junior students, and onto your Facebook and onto your Instagram and onto your Twitter accounts. If you think that is proper, then like this video and also subscribe my channel. So it's a great blessing for me to be able to helpful to so many students around the world. It's a great blessing, sir. Keep praying for me. Thank you very much. Have a good day. God bless you.